Hey everyone. I'm going to be talking about table views today. And specifically, we're going to do three things. Once we implement the table view, we're going to make it generic. The second thing we'll do is we'll add undo functionality to our table view. And then the third thing we'll do is pull out a complex initializer into a configuration struct. Can you not hear me? Yeah, I'll try to lean in like this. I'll be bent a little bit. Just raise hands if you cannot hear me, if I forget. OK, so let's create a table view controller. I have an empty one here. And the first thing we're going to do is store an array in there to display. So we're going to create an array items. And this is going to be an array of people. Now we need to create an initializer for this as well. Sorry, it's an array of person. The initializer gets the array as well. So we get in the items and the style, UITableView style. And then we need to set those properties. First, we need to set the items. And only then we can call super. Now, here we need to pass in the items as well. And there's one more thing to do. The table view wants an extra initializer. And we can press the magic shortcut. Control, Option, Command F. It means fix all issues. Very useful. So we're not displaying the cells yet. Let's do that. Hopefully everybody knows how to do it, but we'll do it together. The first thing is that we need to implement table view number of rows in section. Again, bad UI, as we've seen earlier today. We just return items that count. The next thing is table view self-erode index path. So what do we do here? I'm going to cheat and create a cell and not dequeue it. In production code, always dequeue. So we pass in a style and no reuse identifier. And then we return it. Now we need to configure the cell. The first thing is getting the item. And now that we have an item and a cell, we can configure it. So we can say cell.textLabel.text equals item.name. And here we go. We have a very simple table view. So what if we want to have a slightly different representation? If we want to use the subtitle style. Now we could change it here, but we can make this a configuration option as well. Cell style. And then we can add a property here. And pass it in the initializer. And store it off. Again, we need to fix our code. Here we pass in the cell style. And what if we want to change the way we configure it? For example, now we want to set the detail text label. Instead of changing it here, again, we can make this a configuration option. And there are two ways to do it. One would be to use protocols. But if we want more flexibility, we can use functions as well. If you are used to object-oriented programming, then you might want to do something like this. Configure a cell, pass in the cell, and the item. And then other people can subclass. However, I like to make my classes final, as you can see here. So how do we do this? Well, instead of a method, we can pass this in as a parameter. So configure cell is a function that, given a cell and an item, configures it. And we need to pass this in as a parameter as well. Configure cell is a function that takes a cell and a person and configures it. And again, we store it off. Now let's scroll down to where we create our table view. We can add a trailing closure. So given the cell and the item, we can say cell.textLabel.text. And do the same for the detail text label. I made some kind of error. Ah, yeah, the in. Thank you. So here you can see that we now have the value 1 style. And if we want to change this to subtitle, we can change it. But what if we want to have a table view controller that shows Pokemon? This is where we can use generics to abstract this person out. So let's do that. We're going to add a generic parameter, item. Now we can replace every person occurrence with item. This is a very mechanical process, and often when you're writing generic classes, it can be very mechanical. And you can see that everything still works. So let's create a Pokédex view controller. So we can pass in the Pokédex. We can use the grouped style, default. And in our configure cell, we get the cell and the item. And then we set cell.textLabel.text to item. Let's see. And we can use it here. So we made it work. We can delete this again and continue with the next part. So let's add editing functionality and undo functionality. Again, we're going to make this a parameter of our initializer, which is starting to get complex. Editable is a Boolean. And then below the initializer, we can create a button for that. If editable, then we can set navigation item, left bar button item equals new UI bar button item. And we just use the edit item, self as the target, and for the selector, we write edit. And this function edit takes a sender, which is any object, and it's going to toggle the editing. At this point, we have to stop using playgrounds. We can fix this. I'm using the current version of Xcode, not the beta, and this is not interactive yet. As we've seen before, with the newer versions, we can make it interactive. However, now we need to move all of this to a separate project. Okay. I'm just going to paste it in here. And I'm going to take this code and move it to the app delegate. And let's run this. Hopefully it still works. OK. So we can click Edit, and we see Edit. Now, to implement the editing, we're only going to implement deletion. So let's do that. We've seen in Daniel's talk how to do that. So we can override table view, commit editing style. We check if we're deleting. Otherwise, we return. And now we can remove from the items. We have to make items a variable. And we can run this, and it will not work. So if we edit, and we delete Ash, nothing happens. If I click again, we get a crash. The problem is the table view is not updating yet. So we need to make that happen. Again, I'm going to take a shortcut and reload the entire table view. So we can use the change. Now we can actually delete. So how to add undo functionality? Well, we're going to create an undo struct for this. And it's going to be generic as well. And we need to initialize it with an initial value, which is an array of items. And in the initializer, we just set it. And how do we keep track of the history? Well, we can simply use an array of items for that. And we start with an empty one. And every time we change something, we push onto this array. So now that we have this, we can also define a value. Now that we have this, we can define a property current value, which is an array of items. And we'll just check for the last item in the history. And if it's nil, then we use the initial value. I forgot to write the setter part. So let's try to use this. We're going to delete this part, and we're going to store a history. And we need to initialize it as well. Now, here we are using items in a couple of places, 3 places. And we can re-add that items functionality as a computed variable. So items is an array of items, and we just return history.currentValue. So we solved 2 of the problems, but we didn't solve changing the items. We can also add that. So the first thing is to add a setter for current value. So the setter just pushes onto the array. And we also need to add a setter for items. Now, hopefully, our compiler is happy. We can use the fix everything for me button and make history a variable. And it seems like the compiler is happy. So let's run it and make sure everything still works. So it's working. We can edit. We can delete. Hopefully. So this is, again, the same problem. We need to make sure that when the history changes that we really reload our table view. And now everything will work again. So let's add the undo part. First, we'll add a function undo. And it removes an item from the history. And this function needs to be marked as mutating because it changes the struct. And now we need to call it, so we need to create a button for that. So we create, again, a UI bar button item, undo, target is self, and the selector is undo. And we need to implement this selector. And then we just call history.undo. So we delete Ash, we delete Natasha, and then we can undo. The reason this works is because arrays are structs. And unfortunately, I would need another 25 minutes to explain how structs work, but it's really, really cool. So let's clean this up a little bit. We're only going to show this if we can actually undo. And we can use the did set of the history. So here we can say if history can undo, we can set the navigation.write bar button item to either the button or nil by asking the history if it can undo. If it cannot, we just set it to nil. Now we need to implement that can undo, which is a Boolean, and it just returns if the history is not empty. And now we see the undo button, and when we press undo and the undo stack is empty, it's gone. So that's nice. We got our undo, and we can expand on this, but the next thing we'll do is make our table view class a little bit simpler. And to do that, we're first going to make it more complicated. So we're going to take all of the initializer parameters and put them into a struct. So I'm going to cut it out and create a new struct. Table view configuration. And it also needs to be generic. And then we need to make these properties. So there's a lot of typing. And finally, you configure cell. Now, to use this, we are now going to pass in a table view configuration. And now we have to use configuration.items everywhere. Configuration.cellStyle. And configuration.editable. And also down here, we need to add this configuration. And let's use fix everything to add the label. So you might think, what did he do? This is way more complicated. But it's actually really nice. So we can take this configuration and stick it into a variable. We can have that variable outside of the app delegate. And if you think about testability, this is great. This is a simple struct, and we can easily test that it's correct. And you can reuse this everywhere. And you only need to test your table view controller once. What you can also do is change it a little bit. So let's imagine that this variable is in a library. What we can now do is change it in our app. So because it's a struct, we can easily make a copy. And then we set the config.style to grouped. And now we can use it. So this is a very powerful technique that I use over and over again. I make a class with a complicated initializer and then pull out everything out of the initializer into a struct. And I get very reusable and testable code. So it still works. And that's all I wanted to code. What I want you to do is to think about if you can use this in your code, and if you can use these patterns in your code base. Specifically, if you can use generics and structs to clean up your code, this can be very beneficial. If you want to play around with this, what I would encourage you is to add moving functionality. You will bump into a limitation with the undo struct, but I'm also sure that you will figure that out and fix it. So that's all I have to say. Thank you.
Thank you very much. I learned a lot. It was a very good presentation. Are you going to disclose this code today somewhere on the website or somewhere?
Yeah.
Are you going to disclose or put out your code? Dawn and Pokemon, and what did you use to come up with that sudden image, and also for Pokemon? What did you use? Yeah, that's the one. How did you do that? What did you use?
I just press F10. You have it on your Mac as well. I'll show you.
Did you use some kind of application? Can you use the microphone, please?
So last night I wanted to add some special effects. And I was very inspired by Tim. So this is the code.
Hi, Chris. Thanks for the talk. Can you maybe give us some other examples of places where you've used this pattern of just generalization and pulling out configuration?
Yes. My favorite example is to do this for networking. So so I gave a talk in Paris, which sort of ended halfway of where we started today. And before the first part, that had networking in it. So what I did there is I started with just a function that loads some data from the network, parses it to JSON, and converts it to person values. And then I pulled that out and ended up with a very simple struct that describes the endpoints of your API. And that struct was very easily testable because it's just a struct. And all the asynchronous code was hidden in one generic place. And it made it very simple to test. I wrote a blog post about this called Tiny Networking, but this was a long time ago. So probably it doesn't compile anymore, but that's good because then you have something to play around with.
Hi. What were the magic keyboard shortcuts that you used to fix the fixable errors? I missed the last.
Yes, it's Control, Option, Command, so all three, and then F. Yes, and so you have to be, I think sometimes it doesn't work when you're inside the error, but you have to be, I think, outside the error. So if you go to this menu, it's this one, Fix All in Scope. And there's also ones to indent, and there's ones to navigate to the next one and the previous one. And the Swift compiler is incredibly helpful with these things.
Thank you.
This time you create the view controller. I don't think you can use it in storyboards. It's a generic class. For storyboards and segues, coordinator patterns, if you use those patterns for storyboards and segues, the patterns disappear. So maybe it's not for Swift. That's my impression. What are your thoughts?
Yes, it's a very valid point. So, okay. So for my last app, Scenery, we used storyboards all over the place for a Mac application. It's a really big storyboard, and I liked it. However, and we also used segues, yes. However, if you want to use this with storyboards, it is possible. So what you can do is you can create another subclass. Let's see. You can create a subclass of the MyTableViewController, and if you don't make it final, and that subclass is not generic, and then you can reuse that code. So that's one possibility. However, I have to agree with Gwen that I also stopped using storyboards more and more, and I really like this moving all the logic outside of the view controller. So I think, or sorry, it was, I'm confused now. With Ayaka, sorry. So if you add this did select, you can also configure that with a callback. And then your view controller can be very dumb, and you can do all the navigation outside of your view controller, which makes it way more reusable. And I think the benefit of that outweighs the benefit of using storyboards. I hope in the future it will become easier to mix and match. But I really think having very dumb view controllers is a really good thing. Anything we can do to make our view controllers dumber and more reusable is great. Yes, okay, thank you.